So now I talk about the Chebyshev filter design. So Butterworth filter design I have done. So I have to now go for the Chebyshev filter design. How do I do that? So what is Chebyshev filter design methods? So Chebyshev filter is based on Chebyshev polynomial. Actually this algorithm, this polynomial used to curve approximation of a curve. So now if you see, when somebody give you the filter specification, this is the 3 dB down omega p, and then it is attenuated further, and this is the attenuation. So I want to just copy this graph only. So basically the Chebyshev approximation is used to copy the desired frequency response of the filter. Okay. So how it is designed? There is two type of design. One is the Chebyshev filter are all pole filter that exhibit equiripple behavior in pass band. So if I allow ripple in the pass band and stop band is monotonic, that means no ripple, then I call type 1. So if this type filters, what is the properties? This is an all pole filter. It is equiripple in pass band and stop band is monotonic. So since stop band is monotonic, there is no ripple, so the attenuation in that stop band is very good. So when I require a stop band attenuation is very good. I want to design an application when I require a stop band should be almost 0. Then I use type 1 Chebyshev approximation, type 1 filter. And what is type 2? It contains both the 0 and pole, but it does not have a ripple in pass band, but it has a ripple in stop band. So type 2 filter has a ripple in stop band, but there is no ripple in pass band. It is a pole 0 filter. So type 2 is a pole 0 filter, type 1 is a all pole filter. So how do I design this type 1 and type 2 filter? Let us say go for the type 1 first. So let us say this is the square magnitude response of the filter. So what is, if you see, what is the extra there in Butterworth filter here? That is epsilon omega by omega p. Here it is not. It is a omega by omega p is a function of Tn square. So Tn of x is called nth order Chebyshev polynomial. Nth order Tn, nth order Chebyshev polynomial is used here. So what is the polynomial? So it is nothing but a T0 of x. X is the inside variable, so x is nothing but a omega by omega p. So x is equal to 1 when n equal to 0. So n is nth order, means if I said small n is varies from 0 to n minus 1. So small n equal to 0 means T0, T1, Tn. So this is a recursive kind of polynomial which is used to approximate the desired frequency response of the filter. Okay. So what is the properties of that polynomial? Number 1, Tnx is less than 1 always for all x. If the x is less than 1, then Tnx also will be less than 1. Magnitude of Tnx will be also less than 1. Tn, if x equal to 1, then Tn1 is nothing but a 1. Maximum amplitude is 1 when x equal to 1. So if x is less than 1, the polynomial value is also less than 1. If the x is equal to 1, polynomial value is 1 for all n, whether it is T0 1 or whether it is T1 1, does not matter, it is always 1. So all roots of the polynomial occur in the interval of -1 to +1. Okay. So, now I come to the, so this is the properties and this is my polynomial, Chebyshev polynomial. So, I use these two properties to design that filter. How do I design it? So, for n odd, Tn0 is equal to 0. That means, if x equal to 0, then what is the value of Tn0? So, Tn0 is equal to 0 if n is odd. So, if the order of the polynomial is odd, then Tn0 is 0. If the order of the polynomial is even, then Tn0 is 1. So, when Tn0 is 0, that means whole things is 0. So, it is nothing but a 1 by 1. So, it is nothing but a 1. Now, when Tn0 is equal to 1, that means at omega equal to 0. So, at omega equal to 0, so this is H0 whole square is nothing but a 1 by epsilon square. Okay. So, at omega, so when I say that, when I approximate that filter, so at omega equal to 0, here it is maximum is 1 in case of n is odd. In case of n is even, this is nothing but a 1 by root over of 1 plus epsilon square. Epsilon is the passband ripple if n is even. Now, at omega equal to omega p, so if I say at omega equal to omega p, Tn omega p by omega p, so omega p by omega p is equal to Tn1. So, Tn1 is always 1. So, I can say this factor is 1. So, it is nothing but a 1 by epsilon square, root over of epsilon square, which is equal to your passband ripple. Now, again you can prove that if the passband edge frequency is defined in 3 dB minus 3 dB, then the passband ripple epsilon will equal to 1. Okay, same principle. Now, I come to the pole location. So, in case of Butterworth filter, the pole location are Sk defined by an, we have derived that equation. So, here also I have to find out the location of the pole. Now, if you see the Chebyshev polynomial in type 1, the Chebyshev filter, that all poles are lie on a ellipse in a S plane. So, it is not like the Butterworth filter, all poles lie on the left hand side of the S plane. Here also left hand side, but it is not in entire left hand side plane. It will be lie on a ellipse. Okay. So, if it is on ellipse, so a ellipse has a two axis, one is called major axis, one is called minor axis. So, major axis, let this one is the major axis, and this one is the minor axis. So, this is R2, this to this is R2, and this to this is R1. So, now if I say this to this radius is, this is R2, here center point to here. So, if I take an R2 as a radius and I can draw a circle. Similarly, I can take a R1 as a radius. So, here to here is in R1. So, R1 as a radius and I can draw a circle. Then what is the value of R2 and R1? So, R2 is equal to omega p into beta square plus 1 divided by 2 beta, where beta is depends on the epsilons. Epsilon is the passband ripple. Okay. If epsilon is equal to 1, then beta is equal to root over of 1 plus 1 plus 1 divided by 1. So, it is nothing but a root 2 plus 1 by 1. Once I know beta, I can calculate R1 and R2 also I can calculate. See, this is minus 1, that is why R2 is less, R2 is always less than, minor axis is always less than the major axis. Okay. So, if I know epsilon, then I calculate beta, I can calculate R1, I can calculate R2. Then where is the pole? The pole location are determined for a filter of order n by first locating the pole on equivalent nth order Butterworth filter that lie on the circle of radius R1 and R2. So, first I use the Butterworth process to find out the location. So, the location will be on the radius of R1 and R2, circle of the radius of R1 and R2. Okay. So, phi k, let us say phi k is equal to pi by 2 plus 2k plus 1 pi divided by 2n. So, phi k is the angle. So, if you see Butterworth filter, that e to the power sk is equal to e to the power j pi by 2n into 2k plus n minus 1. What is the meaning? E to the power j pi by 2n into 2k, let us say 2k minus 1 divided by into plus e to the power or into e to the power j pi by 2n into n cancels, so j pi by 2. So, I can say the pole position, if I want to so this upper side is the angle. So, pole position are determined from that angle. So, phi. So, phi k. So, phi k equal to 0 means phi 0 is equal to pi by 2. Why it is pi by 2? Why offset is required? Because all poles are in the left side. So, this is pi by 2. So, pi by 2 plus this side, pi by 2 plus 2k plus 1 pi by 2n, where k equal to 0 to, it may be, I think it will be minus 1, there is a mistake, it will be minus 1, because this is the Butterworth filter things. Okay. So, once I know phi k, so I am locating the pole on the radius in here. Okay. So, if you see, this axis is my x axis. So, x axis is related to R2 and y axis is related to R1. So, if I say the poles are located in here, I can say that x value is xk. So, xk is equal to R2 cos phi. So, this is phi k, angle is phi k. So, phi k angle is this one. So, I can say it is nothing but a R2. So, this portion is nothing but a R2 cos phi. And y1 is nothing but a R. So, if this is phi, then y can in case of sin phi. Is it okay? So, R2 cos phi k and R1, so this is phi k. Think about pi by 2 plus this one. So, this portion R2 up to this portion is nothing but, I can say it is nothing but a x is nothing but a R2, this is phi k. So, this is the radius, R2 cos phi k is the xk. Then what is yk in this axis? In ellipse, this is ellipse, this point is in ellipse xk yk. So, this is nothing but a R1 sin phi k. So, I know that in case of type 1 filter, a pole position is xk is equal to R2 cos phi k and yk is equal to R1 sin phi k. So, if I know phi k, R2 and R1, I can find out the value of xk and yk. Okay. So, this is the pole position. I'll show you one example so that you understand. Let's should I give the example right now and then go for the let's say cover the type 2 and then give you the example. Okay. So, the pole position is xk yk. So, how it is come to the pole, I will show you. Okay. Then Chebyshev filter type 2. Type 2 filter. Type 2 filter magnitude response is this one. Okay. And again all are same, and here xk is equal to j pi k j omega s by 0 are located. So, it is a pole 0 filter. 0 are located at sk equal to j omega s by sin phi k, and poles are located at the point of vk wk, where vk is this one and wk is this one. Omega s sk divided by root over of sk yk root over of xk yk square. Again you can say beta is equal to this one. So, I can say that if I know R1 and R2 from the beta, and once I know the R1 R2, I know xk yk. Once I know xk yk, I can say vk wk calculated. Okay. Then again, how do I determine the order? So, order equation is this one. So, if I know delta 2 and ripple, passband ripple or stopband ripple, I can design I can find out the order of the filter. This is the relationship. Let us give an example. Determine the order and pole of type 1 low pass Chebyshev filter that has an 1 dB ripple in the passband, a cutoff frequency 500 Hz, at a stopband frequency 1 kHz and an attenuation on 40 dB. So, first from that verbose things, first you draw the filter. So, this is my omega axis and this axis is my in dB, let us say in dB. So, let us say this is my 0 dB, let us say. Then I say determine the type of low pass filter has an 1 dB ripple in the passband. So, 1 dB ripple in the passband means epsilon. Epsilon I have to calculate. So, there is a ripple in passband, 1 dB ripple, and omega p is 500 Hz. So, Fp is given 500 Hz and stopband edge frequency is 1 kHz. I have to determine the order and pole position of the filter. Okay. So, what is the order of the first find out that epsilon. So, epsilon is nothing but a 10 log 1 by epsilon square is equal to 1 dB. So, I can calculate epsilon. Once I calculate epsilon, I can calculate epsilon is known, then attenuation at 40 dB or more. So, let us say 40 dB. So, if it is 40 dB, then delta 2 is equal to 0.1. Okay. So, delta 2 equal to 0.1, and order I put the delta 2 value and epsilon value, I calculate the order 4. Okay. Now, once I calculate the type 1, so beta is equal to this equation, I put the value of epsilon 0.5008 in here, I find out the beta value is 1.429. Then I can calculate R1, I can calculate R2, I can calculate phi k. So, what is phi k? Is phi k is equal to pi by 2 plus 2k minus 1 or plus 1, whatever, let us say plus 1 divided by 2 into n equal to 4 means 8. Then k equal to 0. So, So, phi 0 I calculate phi 0, phi 1, phi 2, phi 3. If it is the real filter, I can say phi 0, there will be a complex conjugate. So, if I only compute 2 value, others will be complex conjugate, I can directly write down. Okay. So, phi 0, what is the value of phi 0? Pi by 2 plus pi by 8. So, it is nothing but it should be plus, it will be not minus. If it is minus, then what will happen? The pole may come to the first coordinate, because this is pi by 2 in the S plane. So, if the pole, all the pole will be the left hand side, not right hand side. So, if it is minus, it may come in right hand side, that is why it will be plus always. So, this will be always plus. Okay. So, it is nothing but I can say 8, 5 pi by 8. So, 5 pi by 8. So, it is nothing but xk, x0 is equal to R2, 0.365 pi, 365 pi into cos 5 pi by 8. So, you can calculate the value of xk, you can calculate the value of yk. So, that is the pole position in the left hand side of the S plane. So, I have an S plane. So, how do I determine the transfer function? Let us say I take a blank slide here. So, how do I determine the transfer function? So, what I said, that all the poles are in my left hand side. So, let us say this is my S plane and this is my ellipse, let us say, and so all the poles, let us say pole in here, this is nothing but a xk, yk. So, this is real axis. So, real axis is related to xk, j omega axis is related to yk. So, I can, the pole is nothing but a sk plus jyk, and another one is complex conjugate xk minus jyk. So, this is one pole, this is another pole. So, once I know the value of xk and jyk, I know S minus, let us say this is sk, sk means pole position. So, S0 is xk plus jyk, let us say. So, I can say S minus S0 into S minus S1 into S minus St, I can go Hs. And what is the 0 location? 0 location is always sk is equal to j by omega s divided by phi k. So, once I know phi k, I can 0 location, I can find out S0, S1, S2, I can find out and I can put it in here, 0 location in the transfer function. So, Ps by Qs. So, that is transfer function is designed. So, that is called Chebyshev filter design. Is it clear? If you have any confusion, then you can comments on that your forum, so that I can clear it out. Okay? Thank you very much.